Welcome, class, to Lesson 7-7. Today, strong mathematicians can make and use line plots to display fractional data. So take out your notebook, your pencil, write down today's date, the name of the lesson, and let's jump right in. As we know, numerators and denominators, here's old hat. Don't even need to really look at this slide, but I still like it as a little reminder in case you got to pause it quick and look at it. And now, what is a line plot? We've seen these before. We probably should have mentioned this a long time when we first showed them, but a line plot is a graph that shows data using a number line. And now you see ours contains a whole bunch of fractions. Down here, we see we have the fraction of 1/4, 3/8, 1/2, 5/8, 3/4, and 1. So we see a lot of now number lines, but now we're seeing number lines that have fractions, and we even notice that all these fractions do not have the same denominator. But the good news is we know we could all make these all to fractions with the same denominator to find equivalent ones. So we're going to dive right in with some questions. Tessa wants to bake raisin bread. She has several recipes that each make one loaf of bread. The line plot shows the numbers of cups of sugar in the recipes. So the first one we're going to ask ourselves is, how many recipes does Tessa have? So you can take a guess, see if your answer matches mine. How do we solve that? You bet. She's going to count the dots. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many recipes? 10 recipes. In my opinion, way too many. Hopefully she'll find her favorite one soon. The next one, how many recipes have more than 1/2 cup of sugar? So how many recipes have more than 1/2 cup of sugar? You can make your guess right now. So have more than 1/2. So here's the 1/2 amount. So we know 3 have exactly 1/2, but have more. The numbers on this side would be greater than 1/2. So I have to include all of these recipes as well. So how many have more than 1/2? Oh, have more. Ooh, I just realized that. These have exactly, these would be equal. So I don't really count these because they have equal. Which ones have more would actually be those two. So it would actually be 5 recipes. That's why it always pays to double check your answers. I was about to say 9, but I read the question again, and that more got me versus saying how many have at least. So remember, those word choice and those words in our problems really need to help us focus. Tessa wants to try all the recipes with exactly 3/4 cup of sugar. How much sugar does she need? Well, let me erase some of my good work here. And we're looking at how much for the, should try the 3/4, exactly 3/4. So these are all the ones that have exactly 3/4. So therefore, we can line this up as a multiplication problem because there's 4 recipes, and each of them use 3/4 cup. So now we can multiply 4 times 3 in our multiplication of fractions. We can do that. We get 12/4, but now we can put this or. 4 divided by 12 is 3, so it would be 3 cups of sugar she would need to make all 4 recipes that have 3/4 cups. So you notice how you answer these questions by using this line plot to help us out. Well, now our goal is to make a line plot with the information used in the table. Answer the following questions. We have width in inches, and we have number of students. So with that, we are going to draw a line. Sure, why not? Let's take this one. We'll draw a line across. That wasn't even what I hit, but oh well. There's my line. We're going to start with a label, because remember, we know things need labels. This is width. And it looks like hands, if I read my question right there. The width of hands in inches. We also need a measurement, because we don't know if we're measuring in centimeters, millimeters, whatnot. We're taking my line and actually move it up a little bit so I have a chance to write some information underneath it. That's a nice part about having a smartboard. And now we can fill in all of our parts. So we're going to make our first line. This is 2 1/4. The next one is 2 3/8. 2 1/2. 2 5/8. 2 3/4. I thought I was going to run out of space. And 2 7/8. And now with that, we put our little X's or dots or circles, whatever you kind of choose, some way to mark ones you have. So 2 1/4 have 1 student. I'm just going to use X's. 2 3/8 has 2. 2 1/2 has 2. 2 5/8 has 4. Must be the common size. Said 2 3/4 has 2. and 2 and 7/8 has 1. So now we're looking at what is the difference between the width of the widest hand and the most common hand width. Whew. Let's figure this out now. So what is the difference? So when I think about difference, I can't say one's bigger than that. I actually want to use a subtraction problem of width of the widest hand. Well, it looks like the widest hand right here would be, this one would be my widest. And the most common hand width, well, it looks like this one right here is my most common because it has 4 people that have that size. So now if I subtract those two, 2 and 7/8 minus 2 and 5/8, I'm glad that the denominators are the same. Makes this pretty straightforward. Whole numbers, 2 minus 2 would go, 7 minus 5, so that would leave me with 2/8 inches. That's a little symbol you can use because we're measuring in inches, or you could have wrote down the word inches or IN for the abbreviation. So you can take a look at this information, maybe make that line chart to help you out, see how we circled things, and use that to actually help us solve a problem from the data we plotted out. Now it's your turn. So you're going to draw a big line on your paper, right? Box 3, now your turn. Molly's wants to make raisin bread. Molly's mixing it up. Not even different bread, still the same raisin bread. But you got 3 questions to ask. How many recipes does Molly have? How many recipes have more than 1/2 cup of sugar? And Molly wants to try all the recipes with exactly 5/8 cup of sugar. How much sugar does she need? You can pause the video now and solve those 3 problems. And last but not least, you're going to make a line plot with the information you use in the table, and then answer the following questions. So make sure you draw the line plot, you label it, you put all the parts on there, and then answer the question. If you're not sure, you always go back and re-watch the example to help you with your problem. Good luck. As always, if you have any questions, comments, or concerns, feel free to write them down or share them out. Also, any strategy that you use to help you, you can share those as well. And as always, thanks again for another great lesson.